Yes, thank you once again, in class. I welcome you to Metric Up and thank you for connecting and tuning on. Today I'm going to quickly go through revision of paper 1 2021, geography 2021. I'm not gonna just waste any time. Please, just like in any case, instructions, I've done them in the first papers. So please, let's just quickly go to the questions and then we won't waste any time. Uh, it's climate and weather and geomorphology. First question one, climate and weather. So I'm just going to quickly answer these questions without wasting any time, just to make sure that it won't take as long as it should be. But I mean, as it is not necessary. So I'm gonna make it very short and fast without delaying and wasting any time. The board is posted there. Various options are given there. Then you write the question number and answer only. First question is reads a mid-latitude cyclone occurs between dash and no, between dash north and south of the equator. A mid-latitude cyclone occurs between it occurs between 30 degrees and 60 degrees north and south of the equator. So this one is not correct. First question, it is not correct. I mean, our first option is not correct. So our answer is what? Is B. A mid-latitude cyclone occurs between 30 degrees north and south uh, of the equator. That's the correct answer on question number one. Question number two, mid-latitude cyclone is steered and it or is driven by a mid-large cyclone is driven by what? It is driven by westerlies. I'm sure that if you can check in our revision or in our notes, we can as we all note together that it is not it is mid-large cyclone is driven by what? By westerlies, which is letter D on question number two. And then the change in the change in direction, the change in wind direction of a mid-like cyclone in the southern hemisphere is called what? It is called what? The change in wind direction of mid-like cyclone in southern hemisphere is called it is called baking. Baking is the correct answer. Baking is the correct answer on number three. So our answer is what? Is B. Is called baking. Uh, the front below is the dash front. I'm sure if you can check this, we talked about types of front. The front below, which is given on this page here. Remember that our front we have got cold front, occluded front, and also warm front. So what I'm saying is that different fronts are shown, and I'm sure that if you can refer again, you will know that different diagrams are used to bring or to explain fronts. A chord front is shown by triangles that are what? That are resting on the what? On the line. That's what we call a chord front. So a home front also is the opposite of that, which is also going to be a what? Semicircles that are also resting on the line, which will show a home front, and then it will show a chord front, and then occlusion is a mix of both. So what we are saying is that the front below is a what? It is a home front, which is letter C on what? On question number 4. Letter C is the correct answer. Letter C is the correct answer. It is a what? It is a home front. I mean, it is a home front, which is shown in this case. And then our next question, question number 5. The mid-latitude cyclone below is in a dash stage. You see, this examiner also was too much. He had just to give a lot of questions on mid-latitude cyclone. So we just need to be armed and get ready for questions such as those. So a mid-latitude cyclone below is in a dash stage. It is, as you can see here, we are saying it is what? It is at a mature stage, which is shown on this question 1.5. We are saying the stage, the mid-like cyclone below is in a dash stage. It is in a dash stage, the stage which this mid-light cyclone is. It is showing that it is what? It is a mature stage. This is a mature stage. You can as well refer and make sure that you see that this is a mature stage which is shown on this diagram. It actually shows a mature stage, which is the stage of the mid-latitude cyclone that is shown here. The conditions experienced behind a cold front are dash. The conditions experienced behind cold front are or in dash. The conditions that are experienced behind a cold front, they are dash. They are in or they are a increase in pressure and decrease in temperature. Behind a cold front, there is an increase in pressure and decrease in temperature, which is correct. Number 6, we are saying there is an increase in pressure and also a decrease in temperature, which is letter what? Which is letter A on number 6. A is the correct answer. And then which symbol below illustrate the merging of a cold and warm front? Which symbol is showing the merging of the merging of a cold and warm front? The merging of a warm and cold front. So we are saying warm must start merging of merging of a cold and warm front. The merging of a cold and warm front. So we are saying which symbol is showing that, which symbol is illustrating the merging of a warm and cold of a cold and warm front. As you can see, I'm saying the merging of a warm and cold front, of a cold and warm front, it is shown clearly by letter what? By letter D. D is the correct answer, which shows the merging of a warm and cold front. As you can see here, I'm saying for the interest of revision, in any other extended explanations, let's refer to the notes also, so therefore we cannot waste time on the revision segment. Next question, number 8. The station model generally associated with the cold front in the southern hemisphere. You can see this examiner, the person who said this paper. Hey, he has had a nice liking on France and on France and the cyclones and stuff. So as you can see, number 1.8, we are saying the station model generally associated with a cold front in southern hemisphere. In southern hemisphere, the station model. This is what this is the Beaufort scale, where symbols are used to represent or to explain the what they are used to explain weather. Symbols are used to explain the weather conditions. So this is I just understand to say this shows the wind direction. Wind direction is shown by that arrow, and then this showing it shows wind speed. It shows the uh, cloud cover condition. Cloud cover conditions are shown by the what? By the circle, which shows whether to say it's overcast, clear sky, and so forth. So which weather condition? So when it is when it is fully shaded like this, it means that this is an overcast condition. And also when it is like this, it shows that this is a clear sky. And then I'm saying this shows overcast weather condition. Overcast weather. So what I'm saying is that a cold front is associated with weather, with which kind of weather. And again, this is in southern hemisphere, hence it must also relate to what? To it must relate also to the wind direction again. So as you can see, we are saying a cold front is associated with what? With overcast conditions and also wind which is blowing northeasterly, or it is which with also that kind of maybe 15 knots wind speed. So what we are saying, I mean, with what you call with this wind speed that is shown there. So what I need you to understand is that what does one full line represent, and then halfway line represent what in terms of wind speed. I'm sure that you are quite you quite remember that one full bar like this one, it represents 10 knots, and then if it is half, it's 15. I mean, it's 5. So that is 30. That is 30 knots. So in this regard, the southern hemisphere weather conditions are associated with what? With diagram with what with weather station, which is overcast conditions, and also north with also this what you call northeasterly wind direction. So these are the weather conditions which are associated with what? With what you call with weather conditions of a cold front in southern hemisphere, which you can see here on what? On question 1.8, it is A. It is A. That is what is the answer there. Question 1.2, we are given also write only the words next to the question number. You only write the words next to the question number here. We are given this diagram here, which is actually showing some, we can say also this is called uh, wind and sea breezes. We can also define it as microclimate, which is a river climate. So I'm saying this one, I always want to remind you that don't go to exam without understanding all these things. Micro weather or microclimate, sorry, microclimate, we can talk about the river climate, you can talk about uh, the issues to do with city climate, which you also need to talk about the urban heat island, which you need also to talk about matters to do with aspects when it comes to the orientation or the direction to which the slope is facing, and so forth and so forth. These also are aspects which you need to understand this during the night, and also we have got downslope winds which are moving from the land into the river. So therefore, we have got also to understand that what is happening with this regard in this regard. So we have got A, and then B, the wind is rising, and then it reaches to level C, which I want you also to see that you should also need to understand what does C represent, and then A is downslope, and then B is uprising or it's upslope, and then let's go to question A. Question first, sorry. A at A cools because of dash radiation. The A at A, the A is cooling. The A at A is cooling because of dash radiation. This is called terrestrial radiation. Terrestrial radiation is the correct answer, which is what? Terrestrial radiation. The correct answer is what? Is terrestrial radiation is the one that causes the A to cool down in this case. Terrestrial radiation. Downward movement of A along the valley slopes occur during the dash. The downward movement of air along the valley slopes during, I mean, occurs during the, it occurs during the what? It occurs during the what? During the night. It occurs during the what? During the night. Night is the correct answer. During the night is the correct answer. So please understand this thing. This question, it wants you to understand the dynamics or the aerospace, the aerodynamics, which we can talk about, the balancing of air in the space, which is caused because of what? Of heat energy budget. I'm sure that you remember in your geography, you understand that the issue of high pressure and low pressure zone, which causes air to move. What actually causes air to move here? High pressure and low pressure thing. That concept, it must make sense for you to understand this air movement, to say what is taking place in this regard. So number 1.3, 1.2.3, a movement from A to B results in a dash wind. A movement in A, I mean from A to B results in a dash wind. Number 1.2.3, it results in what? in katabatic winds. It results in katabatic winds. Katabatic winds results in air movement from A to B. As you can see, there is downslope wind. We say that is called what? Katabatic winds. It results in katabatic winds where A is moving from A. We are saying from A to B. This results in what? In katabatic. Sorry. It results in katabatic. It results in katabatic winds. That is actually what you need to know in terms of what? In air movement from A to B. And then 1.2.4, dew point temperature drops below, dew point temperature drops to below freezing point at dash, at point, dew point, it is the point, it is just a freezing point. Dew point temperature drops to below freezing point at dash A or B at night. What is the correct answer here? Dew point temperature drops to below freezing point at A or B. It drops to below freezing point at what? Which is, it drops to below freezing point at what? At B. At B. B is the correct answer. At what? At B is the correct answer at 1.2.4. Dew point temperature drops to below freezing point at B. Number 1.2.5, precipitation that forms at the base, the precipitation that forms at B when dew point temperature drops below 0 degrees Celsius is dash. The precipitation that forms at B, we are talking about the form of rainfall that forms at B when dew point temperature drops to below 0 degrees Celsius. What is it called? What is it called? Most of the times we have seen that some books, they talk about what? They talk about, I'm saying, this what we call frosty pockets and so forth and so forth. But in this case, we are saying the precipitation that forms at B when the dew point temperature drops below 0 degrees. What is it called? It is called what? It's called frost. Frosty. I'm sure that you know very well that we find at the base of the river some frosty pockets where frost is forming within some grooves or within the river banks, which we are saying the answer is what? Is frosty. Is frost. Is that form of precipitation is called what? At B. At B there. We say that we have got frosty form of precipitation. It is frosty. And then displaced air from the valley results in a dash in inversion layer or thermal belt developing at sea. We are saying this displaced air from the valley results in a dash when the air is displaced. When the air falls there, we are saying the warm air, it rises, and then what does it form at sea there? We call that it forms a what? A thermal belt, which is also called inversion layer. This one is called inversion layer. This is called inversion layer. C forms what is called inversion layer. It calls inversion layer. This is an inversion layer at C there, which you call that also thermal belt. Thermal belt is also correct. Inversion layer or thermal belt is one, and is we can say that inversion layer or thermal belt, we are two more or less talking about one thing. So what I'm saying is that the thermal belt at sea is formed as the displacement of the air, that warm moist air that rises there, and then it forms, and then it rises to a certain level, and then it forms a what? It forms a thermal. we are saying it forms a thermal belt. It forms a thermal belt. And then number 7, layer C is more developed during the dash. It is more developed during the night. Layer C is most developed during the night, class. This layer C is most developed during the night. It is most developed during the night, as you can see that these are downslope winds, air moving from A to B there, which we are saying the land A is moving from what? From the land into the river. And then we are saying when that happens, we call that what we call this, like I said, it's under microclimate. So please understand this air movement, the land and sea breezes. That is one key chapter also, which must be just taken note of by a geography learner just when you are going to write paper 1 examination. 1.3 is refer to the infographic on tropical cyclone Elos, Elos in numbers, and then description of the disaster. The tropical cyclone Elos made landfall on 23 January 2021, 20 kilometers south of Beira in Mozambique as a category 2 tropical cyclone. Wind speeds of up to 160 kilometers per hour were recorded. Tropical cyclone Elos also also caused heavy rainfall with 250 millimeters of rain in 24 hours. Other areas were already flooded ahead of the Elos landfall, resulting in thousands of displaced people. So people were moved. And then we have got displaced people, death, injured, houses destroyed. These are the statistics of effects of the disaster, which is actually seen or displayed on the table there. And then we have got the movement of LOC, which is 21 January at 12 o'clock, wind speed, which was 12 kilometers per hour. And then we are shown that Mozambique and then Indian Ocean, Madagascar, these are all seen and shown in different, as to say, the times that it was arriving and reaching, hitting different places. Obviously, as you can see, this is the path of the cyclone. This shows the path of the cyclone that is shown there. Path of the cyclone that is shown there, and then give one piece of evidence that, in the infographic, that the tropical cyclone is in southern hemisphere. What information can show us that this information or this give one piece of information, one piece of evidence to show that the tropical cyclone is in southern hemisphere. So what we need to understand is that what is the information that can show that this cyclone is in southern hemisphere. We can understand that southern hemisphere. We can start by understanding that Mozambique. Where is Mozambique located? Mozambique is located in southern hemisphere. We are saying that this is to say that the appearance of Mozambique, the date Mozambique appearing, it shows that we are saying place affected. Place affected in this case, Mozambique. It actually shows that this is in southern hemisphere. I'm sure you know very well that the location of Mozambique on our map, where is it located? And then we also talk about, we can also identify that there is also Madagascar again, which is also shown on this. We have got also Madagascar, which is also showing that it is what? It is southern hemisphere. We have got Madagascar here. We can also talk about also the direction of movement, southwesterly movement. It shows also The southwesterly movement also shows that it is in southern hemisphere. Southwesterly movement. The southwesterly movement also identifies that this cyclone is southern hemisphere. We can also look in the clockwise circulation symbol, which is showing there. The clockwise circulation symbol is another thing there. Clockwise circulation, the clockwise circulation symbol also it shows that this is in southern hemisphere. It can also show that it is in southern hemisphere. Clockwise circulation symbol. What else can we see in this on this information? Uh, we also maybe look at the map of Southern Africa, which is also maybe showing here the map of Southern Africa. This is the map of Southern Africa is also shown. The map of Southern Africa. It is visible on our what map of Southern Africa. It also shows that this is in Southern Hemisphere. We can also see that I'm sure that the issues of Beira and so forth, Mozambique, is one thing that we can also talk about in terms of that direction. And then let's quickly go to the next question. State two weather conditions associated with tropical cyclones indicated in the what in this question. Two weather conditions associated with this. I can see that we have heard of heavy rainfall of 250 millimeters. Heavy rainfall. We are told of the heavy rainfall here. Heavy rainfall of 250 millimeters. Heavy rainfall. Heavy rainfall 250 millimeters that is recorded there is a weather condition that is shown there. 250 millimeters is shown in that question. It's weather condition there, and then we also told of the wind speed. We are also told of the wind speed, which is told that the wind speed 160 kilometers per hour. High wind speed of 160 kilometers per hour. High wind speed of up to, which is of up to how much? 160 kilometers per hour. Up to 160 kilometers, up to 160 kilometers per hour, which is given in question there. High rainfall and high wind speed of up to 150 kilometers per hour. And then give one reason, question 1.3.3. Question 1.3.3, give one reason for the decrease in wind speed from 19 January to 20 January 2021. What can be the reason of decrease in wind speed? Decrease in wind speed. Decrease in wind speed can be caused by various factors. It can be because of maybe the system is moving over the land. Remember, if we talk about tropical cyclone, once they move over the land, we are saying, I'm sure that we understand matters to do with friction. So it can be because of increased frictional drag. One, increased frictional drag. We are saying the wind is it is moving over the land, hence the resistance, the frictional force. Increased frictional drag can reduce the wind speed. It can also be caused because of It can also be because of decrease in moisture level. It can also be caused because of decrease in moisture level. Decrease in decrease in moisture level. Remember, moisture level is very important, which is supposed to provide with what? With the latent heat of vaporization. So we can also say that it can be also decrease in latent heat. That can also be another additional point to suggest a decrease in latent heat. Remember, this latent heat, it actually provides the sustenance of the cyclone. So decrease in latent heat, it also suggests that the cyclone may also be what? Might also have, uh, it might also decrease the speed as well. So such reasons can also make good sense. Last but not least, it can also be said the system is moving over the land. The system was moving, it was moving over the land. Therefore, the speed can decrease from 19th to 20th of January, the same year. We are saying the system was moving over the land, hence the speed might also decrease. Let's go to next question. Let's go to next question, question 1.4, 1.34, question 1.3.4. Account for the increase in wind speed of tropical cyclones from the same other year. There we are saying account for the increase in the speed. Account account for the increase in speed. Account for the increase in speed. Account for the increase in speed, which is from 20 January to 2022, account for the increase in speed. I can write this question below here just to make to give answers clear. 1.3.4, the increase in speed. What can cause the increase in speed? One, we can talk about it was movement of the, it can be movement, we are saying movement over the whole Mozambique channel. It was moving, the cyclone was movement over the home Mozambique, Mozambique channel can be the reason why there was an increase in speed. It might have increased speed because it moved over the whole Mozambican channel. Question 1.3.4. Question 1.3.4 class. The increase in speed, we are saying it might be because of movement over the whole Mozambican current channel. Movement over the whole Mozambique channel can be the reason why there was an increase in speed. We can also maybe have to say that it was because of factors that we said before. They are now being forfeited. Less less frictional force, less frictional less frictional force might be also the reason why there was an increase in speed there. And then we can also maybe talk about maybe there was increase in high temperatures, or we can talk about high temperatures, availability of high temperatures, availability of high temperatures, which would also contain or provide the what, the the latent heat that we're talking about. And then we can also maybe account to say that increased condensation results in release of latent heat, increased condensation may have resulted in increase in latent may have resulted in increase in release of latent heat. So those points can also be able to avoid or to make sure that these can also increase what can also cause the increase in the speed there. And then question 1.1.3.5, according to the infographic the negative impact of tropical cyclone Helios was devastating, which means it was so destroying. Suggest three strategies that could be put in place to reduce this impact. Ways to reduce the impact of what? Ways to reduce the impact, precautionary measures or management strategies to reduce the impact of cyclone. 1.3.5. We can say that precautionary measures or strategies to reduce impact of tropical cyclone. What can be done to reduce the impact of tropical cyclone? What can be done to reduce the impact of tropical cyclone? We can give so many answers in this regard. One, we are saying giving early warning systems to put in place, giving early warning systems can actually help in terms of making sure that people are aware of the tropical cyclones that are coming. We can also talk about moving people to higher ground to higher ground to higher moving people to higher ground. We can talk about request national and international help, request for national and international help or intervention that can also help in terms of alleviating the effects of tropical cyclones. We can also talk about good forecasting and also the use of media to update regularly. Ensuring good forecasting and update and updating people regularly. That would also help that people are always up to date with what is gonna happen. That is gonna also help. We can also talk about education awareness and education, putting awareness and education programs, putting awareness and education programs about effects of tropical cyclone. This will also help people to make sure that when disasters are to happen, what is it that they can do? Putting awareness and education programs, that is to help people such that they can also be what that can also be able to make sure that they are not ignorant of the effects of tropical cyclone. We can also talk about evacuation protocols and drills, putting evacuation protocols and drills. This will also help to save people also on the problems that would help up, and then stocking up of emergency supplies and necessities. Stocking up of emergency supplies and necessities. This can also help to ensure that when people are trapped, they can be able to survive. We can also talk about matters to do with tracking the movement of the tropical cyclone. Those can also put in place that people are told about the pathway the tropical cyclones are to move. Uh, we can as well maybe add on terms of reinforcement of the existing infrastructure. The infrastructure must be what must be strengthened, strengthening of existing infrastructure such that people can also be safe. This can also be able to save people's lives. We can also talk about maybe measures to do with what is this one? What else can I add here? Maybe you can talk about this one, which has to do putting of sandbags to reduce flooding. Measures that has to do with reducing of flooding by putting sandbags on river banks and stuff that could, or artificial embankment. This can also help to reduce impact of flooding and so forth. So actually we can see that there are quite a lot of points that we can put with regard to this one. Refer to South African Synoptic weather map. Refer to South African Synoptic weather map that is given there. And then we are given that this is Cape Town and Port Elizabeth. We are given Cape Town and we have got high pressure cell. And then we have got also Port Elizabeth that is given there. So we have got our weather conditions that are given there. Morning and afternoon temperatures, which are given 20 and 19. And also we have got our overcast weather conditions that are there. So what is the question saying? The question is saying identify low pressure system A. Identify low pressure system A on the synoptic weather map. It is what? This is a low pressure system. Why is it there? We are saying this low pressure system A, we can talk about it as a what? We can say it is a thermal law. This can be defined as a thermal law, can be correct to say that it's a thermal law. And then our next question, give a reason for the formation of this low pressure system over the interior. Why is it formed over the interior? It is because of what? What is causing this low pressure system to be formed over the interior? We can talk about the what? Because of high temperatures that are also causing rising warm air that creates low pressure system. High temperatures that are there. We have got high temperatures that are causing 20, 38 degrees Celsius. So it is because of high temperatures, high temperatures, high temperatures which are causing rising warm air to create low pressure system, causing rising warm air. It is causing rising warm air to create low pressure, which is to create what? To create the low pressure system, to create low pressure systems that are there. I'm sure you can see, as you can see at A, we are saying there is always, as you can see, the overcast conditions are caused because of too much uh, water vapor in the atmosphere that you are seeing there. There is an overcast weather condition, which is caused because of what? Because of intense rising warm moist air. So there is warm temperatures that are causing rising warm air to create a low pressure system, which is the thermal law that we are talking about there. And then question 1.4.3 give evidence from the synoptic weather map that the South Atlantic eye is reaching. What is showing that the South Atlantic eye is reaching? What is there? We can actually understand that there is what? There is, we can talk about the eyes, the effect to do with, uh, on the map that shows that South Atlantic eye is reaching. I'm saying we can have to understand the effect of what? Of the elongation of the isobars. One, we can talk about the elongation of the isobars, elongation of isobars, which is very, and also the bending of isobars towards the low pressures. The isobars, they do bend towards the low pressure. They do bend towards the low pressure, as you can see. We can see that the isobars, as you can see there, we are saying they are bending towards the low pressure. They are bending towards the low pressure there. They are not straight, but they start to move somehow in the what? As you can see, these isobars, we are saying towards the low pressure, they are bending, they are not straight, which is showing that the elongation and also the bending of the what? Of the isobars towards the low pressure. And then there is also the isobars, they bend or they elongate towards the coastline. Isobars, the isobars, they also bend towards the what? The coastline. But we can as well talk about the outwards extension or bulging of isobars away from the high pressure center. Isobars bend outwards, they bend outwards from the high pressure center of the high pressure center. So these are some of the reasons that we can give with regard to what is happening on question 1.4.3. Let's quickly go to question. Let's go to question 1.4.4. 1.4.4. Why does the region of the South Atlantic high result in onshore winds? Why does the region of South Atlantic Why does the region of South Atlantic, why does the region of South Atlantic, the South Atlantic, result in onshore winds? It is actually because of the anticyclonic circulation. These are the reasons that normally does causes that. It's because of cyclonic anticyclonic circulation. It can be because of anticyclonic circulation that is also taking place there. And then it is because of the anticyclonic circulation. It can also because the ridge extends towards the land also. Because the ridge extends towards the land. Because the ridge extends towards the land. Question number 1.5, 1.4.5. Question 1.4.5. Describe the weather conditions at Port Elizabeth as a result of the onshore wind. The weather conditions at Port Elizabeth. Weather conditions at Port Elizabeth because of onshore winds. We can say weather conditions at PE because of onshore winds. Because of onshore winds. So what are these things? One, we can say it results in what? In also anticyclonic circulation from the high pressure. Results in anticyclonic circulation. Anticyclonic. It results in anticyclonic circulation. Anticyclonic circulation from the high pressure. From high pressure. That is the weather conditions in at PE because of shore. It results in anticyclonic circulation because of the high pressure. We can talk about increase in wind speed. Increase in wind speed is number 2. Increase in wind speed. Increase in wind speed. The wind speed, we can talk about those as Gulf force winds. The Gulf force winds, we can speak of those as Gulf force winds that we can also have, that can also happen there. And then we can talk about forms also to say overcast conditions may also result. Overcast conditions. Overcast conditions, we can also talk about that, which can talk about overcast conditions, which increases the cloud cover there, which increases the cloud cover. Overcast, obviously, they increase what? They increase the cloud cover. We can also maybe talk about increasing, we can talk about increase in what? Increase in humidity. Increase in humidity. Increase in humidity is also another point that is quite making sense, that because of the anticyclonic conditions again, we are saying at Port Elizabeth, they can also, the air is so humid, it's so moist. There is whole moist, I mean, there is so quite a moist air in the atmosphere there. And then maybe last but not least, we can talk about we can also talk about decrease also in what? Decrease in air temperature, which is as a result of the air advancing onto the lands. Decrease in air temperature also. Decrease in air temperature. We are saying these are some of the weather conditions that can result or that can occur at Port Elizabeth. Weather conditions at Port Elizabeth because of onshore winds. These are some of the factors or weather conditions that can occur there. So let's just quickly go to the next question. It's infographic of South African beige wind. Record-breaking heat waves hits East London, Matthew Field, March 2021. And then we are also having the cold, we are having our cold front there. And then we have got a low pressure cell there. And then we are saying East London residents were subject to sweltering heat last Saturday after a record-breaking heat wave resulted in peak temperatures of 43.9 degrees Celsius, according to South African Weather Services. The heat wave was as a result of bad winds. It was as a result of bad wind conditions, and then when hot, dry winds blow down the overcast over the coast from the country's central plateau, then we are given that this is the temperature which was actually increasing so rapidly, and then we are talking about the hours, almost like to say the whole day from 1 up to 23 hours, and then the temperatures went extremely high from around 11 o'clock up to 1 o'clock. They went so up, and then it started to fluctuate again and went up again at 21 hours, as you can see on on this on this on this on these peak given readings there. So the question is saying name the name two name two pressure systems name two pressure systems that are necessary for bridge winds to develop. Two pressure systems. I'm sure if you can refer again, this is also explained on the channel. I talked about bridge winds. Bridge winds. It's also explained on the channel class. Check on the notes also on lectures that are posted on the channel. So name two pressure systems that are necessary for bridge winds to form. One, it is the Kalahari. Number 1.2.5, we are saying Kalahari. Obviously, the Kalahari high pressure, it must be there. Two, we can also talk about the coastal low. We are saying two pressure systems that are necessary for the bridge wind to form. The Kalahari high pressure and the coastal low. They just basically support the formation of what? Of bridge winds. And then determine the highest temperature that was recorded on 13 March. The highest temperature that was recorded on 13 March. We can check from there highest temperature, which was almost 44 point, which was almost 44 point, maybe 44 degrees Celsius, or you can say 44.1 degrees Celsius, which is the highest, is this one, which is shown here, which we can say 44.1 degrees Celsius. 44.1 degrees Celsius can be correct. We can say that 44.1 degrees Celsius, which was almost to 45 degrees there. So we can say 40, 41, 42, 43, 44. So each line is representing a degree. So we are saying 41, 42, 43, 44. So we are having our 40, which is also between, so it is 40, somewhere like 44 to 40, 44 to 40, 44 to 41 point, to 44.1 degrees Celsius, the highest temperature. The highest temperature that was recorded on that highest temperature recorded 44.1 or 44 degrees Celsius, 44 or 44.1 degrees Celsius, that is shown there. And then the next question is saying, what role did the escarpment play in increasing the temperature of the bridge winds between 10 o'clock to 2 o'clock? What role does this escarpment do? Question, we can say one, what role does it do? So we are saying it can cause one, the escarpment, basically you should understand that the escarpment has a greatest vertical height, or escarpment has got a greater elevation. So what we are saying is that again, that greater frictional drag as a result, greater frictional drag as air moves down the escarpment, Therefore, it increases the air temperature. Uh, Air increases the temperature as it moves down the escarpment. That is one thing, because if you can read there from 10 o'clock, from 10 o'clock to 2 o'clock, you can actually see that the temperature went up from 10. This is from 10 to 2. We are saying the temperature, we are saying this time here, it is the temperature where the temperature increased quite a lot. So what we are saying is that increases the temperature as it moves down the escarpment. As it moves down the escarpment, the air temperature increases. It increases the temperature as it moves down the escarpment. That is number one. Number two, one other point that we can talk about there is that there is also one other point which has to do with that uh, A is a greater vertical descent down the escarpment, and then it heats up more. A, it has greater vertical descent, greater vertical descent, and therefore it heats up more. Descent, and it heats up more. It heats up more. That is quite true, that we can see that escarpment has to do with that. Obviously, we can also maybe just talk about these. All things has to do with everything that is happening here is that it has everything to do with an increase in heating up of the air, which is due to that to say that the air at every what you call 100 meters, it also heats by 1 degree Celsius. So these are some of the points that we can just mention with regard to this effect of the escarpment. Question 1.5.4. Question 1.5.4. In a paragraph of approximately 8 lines, explain the impact of beige wind conditions on the physical environment. Effect of beige wind conditions. We can talk about drying out of, obviously we are talking about these extreme temperatures. One, we can talk about natural vegetation or pasture dry out due to very hot, dry winds. Plants or vegetation, they can dry out due to very hot, we have got very hot, dry winds. They can cause the vegetation and plants also to die. We can also talk about the reduction in biodiversity of both flora and plants and animals. Reduction in biodiversity. That is, e.g., both plants and animals. They can also be what? They can also be reduced in number because of this reduction in biodiversity because of these extreme temperatures that we are talking about. As you can see, this has also been explained on the channel again, the effects of Berg winds, but for the sake of maybe others who might not have talked about, have read through it, I just need to mention this in passing. So therefore, I keep my students well connected. It can also cause high evaporation, which also reduces, we are talking about high evaporation rates, reducing soil moisture, which is also a physical effect or a physical impact. Uh, that can also maybe we can talk about disruption of natural ecosystems, disruption of natural ecosystems. Our natural ecosystems are disrupted or are destabilized, which we can talk about either, or also we can talk about what food chain is to say that they can as well be what they can as well be disturbed. Mhm. Let us just quickly answer question two. Question two, various options are provided as possible answers to the following questions. Choose the answer and write only the letter next to the question numbers that are there. So we are given that question there. We are given those questions which are given there. So it is a river system which is points X, A, X, Y, Z, X, Y, and Z shows the different stage courses from the source to the mouth of the river and the points S to ST are along the meander found at Z. That is the meander that is founding this meander is found. This meander is found at Z. And then what is happening here is that please note that this question is saying you need to understand that this is a long profile of a river channel from the source to the mouth. So we are saying it is from the source and then to the mouth, which is given here. From the source to the mouth as it enters the sea. So let's just quickly see the questions that are there. 2.1.1 is saying the profile from the source to the mouth shows the dash of the river. The profile from the source from the source to the mouth, it shows dash. It shows the dash of a river. 2.1.1. It shows the length. Obviously, it is the length from the source to the mouth. It shows the length of the river channel, which is the stages or courses represented by X, Y, and Z are dash X, Y, and Z. X, Y, and Z. These are showing that it is the upper course, middle course, and the lower course. Obviously, it is the upper course, middle course, and lower course, which is letter C. And then dash describes the river valley at X. Dash describes the river valley at X. At X, what describes the river valley at X? Dash describes the river valley at X. It is the upper course. So in the upper course, we have got in the upper course, obviously the river is narrow and deep. River in upper course is narrow and deep, which is letter D. You understand? And then next question. Next question is that at Z, the river has a has a laminar flow due to dash. At Z, the river has got a laminar flow, which is in the lower course. We are saying at Z, which is in the lower course there. At Z, we have got a laminar flow. What is causing the laminar flow at Z? That is what the question is asking. At Z, the river has got a laminar flow due to what? What is causing the laminar flow at Z? So we can just want to look at that to say what is causing the laminar flow at Z. It is the laminar at Z, the river has a laminar flow due to a ditch river bed. It is due to what? It is due to a gently sloping and even river bed. It is gently sloping and even river bed, which can be given as to say C can make the answer Slope T on the meander is the dash slope. Slope T on the meander, slope T at the meander, that slope T there is a dash slope. Slope T at the meander is a dash slope. On question 2.1.5, slope T on the meander is dash slope, which is when you look there, we always have these questions such as to say the issue to do with the meandering of the river canal. We have the slip off, we have the undercut, and so forth. So slope T, as you can see there, the slope there, which is shown at C, it is actually showing a what? It is an undercut. T is showing an undercut. Slope T is an undercut, which is showing that the answer is what? Number 2.1.5. It is an undercut, which is letter C also. It's an undercut at C. And then slope S on the meander is associated with a dash. Slope S is associated with slope S. The slope S here, what I was saying is that it is the what? Slope S. I also had this question, or I had also a description of the long profile of a river, and also the issues to do uh, with this meandering river channel. So slope S on a meander is associated with what? Which is associated with the convex slope with deposition, as you can see, which is shown in that question. What it is actually associated with what? Convex and deposition that is taking place on slope S there. You can see this is deposition taking place there. There's deposition taking place at S. So deposition would always take place, and therefore it is the answer which is correct on slope S is convex slope with deposition, which is letter D. And then the narrowing of the neck in the meander will eventually form an oxbow leg. I'm sure that you know that when when this happens, the narrowing of the meander as it narrows there, we are saying this part is going to be cut off, and then we are going to find out that this part C, or this part which is showing, which is forming here, we call that an oxbow leg because it's cut off the neck of this part as it is there. It is actually going to be cut off, and then we will have that, as to say it will form something like this, and then the river flows there. So this is called an oxbow. It's called an oxbow leg. So the letter is what? The neck can be cut off and then result in an oxbow leg being formed. Question 2.1.8, the meander will migrate on the Dutch floodplain. The meander will migrate how? How does the meander migrate on the floodplain? It actually migrates laterally. It migrates just across or laterally. That is to say that it moves just which is letter B. It migrates laterally along the floodplain, or migrate laterally on the floodplain. Question 2.2. This is a waterfall, which you can also know to say that it is found on the upper course of a river channel. And then obviously there is a plunge pool which is formed at the base of the of the waterfall. And then this is representing what? Hard rock, and then this is representing soft. In the hard rock there is being shown there. So let's just quickly see what is forming there, what is happening. Question 2.1.1, 2.2.1 is saying waterfall forms when there is alternative layers of hard rock and soft rock. When there are only soft rocks, waterfalls are forming when there is what? There is alternative hard and soft rock. So the answer is what? Is X. Waterfall are likely to be found in the upper course of a river channel. That is also correct. Waterfalls are found on the upper course of a river channel. And then uh, number 2.2.3, dash refers to softer rock that erodes faster. The softer rock that erodes faster, obviously, if we can look on this, softer rock that erodes faster, it is what? It is A. A, A shows the softer rock that can erode faster. So, which is what? Number 2.2.3, we are saying it is uh, the rock A, which is letter X again, which is showing that there is the softer rock that erodes faster. The plunge pool is formed by obviously the plunge pool, it is formed by what? What happens there is that at the base of the river channel, the plunge pool, which we are seeing there, number 2.2.4, the plunge pool is formed by what? By erosion. We don't have deposition there. What happens there is that the residues or these rock pieces which are forming the overhang when they peel off or when they break, they come here and then they are moved to cause some swelling and movement of what? Some what you call turbulent movement here, which will cause what? Erosion, or which are caused by erosion. Hence we are saying that the plunge pool is formed by what? By erosion, which is responsible for that. When the softer rock at sea erodes, it will cause dash. When the softer rock erodes at sea, it will cause. When the softer rock erodes, our softer rock at sea erodes, it will form at sea. What does it form? It will form what? When the softer rock erodes at sea, obviously, when this one, what is the question saying is that it is referring to the migration which will take place to say the softer rock is eaten inward here, and then will remain with the overhang only there. So the overhang which is formed there, what happens there is that the rock at A to collapse into the plunge pool. It will also cause the overhang at A to what? To collapse into the plunge pool 2.2.5. It will cause the overhang to collapse. It will cause the overhang. It cause the rock at A to collapse into the plunge pool, which we are saying is the most correct one, which can form there. And then the retreat of the waterfall will result in the formation of a dash. The retreat of the waterfall, obviously, as that overhang collapsing, the retreat of the the retreat of the waterfall, it will result in what? It will result in a gorge. A gorge is formed. The rapid are just very small of outstanding rock outcrops that are found there, but this one is a deep and very, very high. Therefore, it is a gorge that is formed. Number 2.7, number 2.7, uh, actually we are saying an average, okay, an advantage of a waterfall is dash. An advantage of a waterfall is actually hydroelectricity that can be generated in at a waterfall. It results in hydroelectricity being generated there. It results in hydroelectricity. 2.2.3 diagram showing drainage patterns. Identify drainage patterns A and B. Identify drainage patterns A and B. Obviously, A, we are saying A, it identifies what? A, it is a trellis drainage pattern. And then B, it is dendritic. Is dendritic. A is trellis and B is what? B is dendritic drainage pattern. Next question is saying differentiate between the underlying rock structures of drainage patterns A and B. Differentiate. We are saying differentiate the underlying rock structures. Actually, A, A, there is alternating layers of hard and soft rocks folded rock structure there, and B is that there is uniformly resistant rock to erosion. A, actually, which we are saying it is formed on alternate layers of hard and soft rocks, is formed on alternating. It is formed on alternate layers of hard and soft rocks, hard and soft rocks, and then B, is formed actually on what? It is formed on rocks that is uniformly resistant to erosion. Formed on rock uh, that is uniformly resistant, to what? To erosion. That is where we find dendritic drainage pattern formed on rock structures that are uniformly resistant to erosion. We found B. A is found on rocks of alternating layers of hard and soft rocks. And then next question is saying, why are the tributaries of the main stream parallel to the other to each other in drainage pattern A? Why are the tributaries of the main stream parallel to each other in the drainage pattern A? What is the reason? It is because actually it is because the streams flow in relation to the folds of the rocks. They flow in relation to folds of the rock. In relation to the folds of the rock. In relation to folds of the rock. Which we can see again that these streams, they flow over softer rocks of the what? Of the valley, which we are saying that they are parallel to each other. The streams flow over soft rocks of the valley. Over softer rocks of the valley, which we are saying these are what? Interflows are parallel, which we causing of the valley, which we can say that they are interflows that are parallel, or interflows that are parallel That is one key thing that you can see with regard to that one. Determine the stream order at point. Determine the stream order. Question 2.2.2.3.4. Stream order at point 1 in drainage B. Stream order at point 1. You remember to say that when we are talking about stream order, we are talking about the interconnection of the streams, which we are saying the streams which are catching their own waters from the catchment area are called first order streams. So we can say when streams of the same order meet together, they form the next highest order. So we are saying this one is order 1, order 1, order 1, But here we have got order 2 here. This is order 1 again. Order 1, order 1. So we remain with order what? We remain with this is order 2 here. We remain with order 2 there. It remains order 2. And then we have got order 1 here and order 1. They form order 2 there. And then this is order 1. So we are saying this is order 2. Order 2 forming together, they meet together and then they form what? They form order 3. At position 1 is order 3 there. So what happens is that streams of the same order, when they meet together, they form the next highest order. The next high order is formed. And then if two streams of the different orders are meeting at a point, they retain the highest order of the two streams that are meeting there. I once also explained this also on the channel. Also refer in terms of the stream orders. So stream orders class is quite a very common question. It is quite a very common question. Understand that streams that catch their own waters are called first order streams. Obviously, when first order streams meet together, they form the next highest order. According to that, until we go wherever we go. So in order number 3, the stream order at position 3, it is stream order what? I mean, at position 1, we have got third order. It is third order as I have calculated to you there. I calculated to you that that is third order because of the orders that I have shown you there. First order, they form second order. And then we are having second order streams that are meeting together at a point, resulting in third order on position 1, which is very correct as I have shown you with that in question. And then 2.35, choose the correct word between brackets to make the statement true. The the higher the order, the dash the drainage density. So the higher the stream order, the higher or the lower the drainage density. We are saying the higher the stream order, the higher the drainage density. So the answer is what? Is higher. The higher the stream order, the higher the drainage density, obviously. As you can see, to say that the higher the stream order, we are saying we have got the density is also connected or it's also defined by the stream order. So the higher the stream order, the higher the what? The drainage density. 2.3.6 refer to drainage pattern B and describe the relationship between drainage density and low rainfall. Drainage density and low rainfall. Question, stream density B. We are saying density B, this is the what? Dendritic drainage pattern. So we are saying describe dendritic drainage pattern in relation to its dendritic drainage pattern. Drainage pattern that is stream, that is B. So describe density and low rainfall total. So in that regard, we can say that the low rainfall will result in lower order drainage density. Low rainfall total, low rainfall total, low rainfall total will result, low rainfall total, it will result in lower drainage density, will result in lower drainage density. It will result in lower drainage density. It will result in lower drainage density. And then drainage density and steep gradient. Drainage density and steep gradient. Actually, in drainage density and steep gradient, we can also say the steep the gradient will result in a high drainage density. The steep the gradient the steep the gradient obviously will result in high drainage density. Will result in high drainage density. Result in higher drainage density. The steeper the gradient, obviously class, if a gradient is, if a landscape has got a steep gradient, what we are saying is that the steep gradient will result in what? In higher drainage density. Obviously, it means more water can easily drain, and then the stoop, as more water can easily drain, what happens is that the gradient will result in higher drainage density, as to say, many streams will form as a result of what? Many streams will form as a result of the landscape that we are talking about, to say that it is steep. So the steep, the gradient will result in what? In higher drainage density. That is what will happen with regard to drainage density and what? And gradient. I mean drainage density and steepness in the steep gradient. 2.4, the diagram below, the diagram shows the floodplain. The diagram refer to the to a diagram of a floodplain that is shown there. We see this is a floodplain. I'm saying which is shown to say that the river as it enters the what? The sea, and then obviously we are saying the floodplain is given there, and then we are having cultivated, this is the floodplain here, and then this space is showing cultivated land. Cultivated, cultivated land is shown there. So what is happening is that, let's quickly check the question. State the the geomorphological process that gave rise to the formation of the floodplain. State the geomorphological process that give rise to the formation of floodplain. Obviously, floodplain are formed as a result of what? Floodplain are caused because of deposition class. Deposition is the process that results in floodplain. It is deposition. Describe the gradient at x, gradient at x, that is floodplain and then cultivated land. Describe the gradient at x. What happens there? This is a gentle flat gradient, because as you can see, we are saying there is floodplain and then there is cultivated land there. So this is at x, it shows, X shows what? It shows a gentle or a flat level ground. This is a gentle or a flat. X is showing a flat level or a gentle. It shows a gentle flat or a level gradient. That is what is happening at X. Gentle, it can be flat, and then level gradient, because you can see that there is accumulation of floodplain or deposits there. And then we also have, which is showing that the river is depositing all this material there. And then around it, we also have what? We have got farming that is taking place. And then question 2.4.3, 2.4.3, suggest two reasons for the wide floodplain at X. Two reasons why there is, it is because 2.2.3, it is the wide floodplain at X. It can be due to increased deposition that is taking place there. It can be due to increased deposition. Deposition can result in a large floodplain there, which can also talk about, it can also because of the gentle slope that reduces velocity of the river. Gentle slope reducing the velocity of the river results in more deposition, velocity of the river, and then obviously more deposition will take place. That will result in more deposition there, and then we can talk about regular flooding that might be taking place in the place. It might happen that there is also regular flooding in the region where X is located. There might be regular flooding that is taking place there in the region, or in the region, we can say the region or area. And then in paragraph of 8, approximate lines explain the physical natural impact of flooding on the floodplain. Impact of flooding, explain the physical impact of flooding on the floodplain. So we want to see what is the impact of flooding on floodplain. One, we can talk about the deposition of fertile soils materials improve the nature and amount of vegetation. Deposition of fertile soils. Deposition of fertile soils. We are saying the deposition of fertile soils also improves the nature and amount of vegetation. Improves nature and amount of vegetation. That can be true. We can also talk about there is also the alluvium deposits. Also, the alluvium deposit increases the quality of the soil. Deposits increases quality of soils that are found there. Alluvial deposits, they increase the types of soils that are found there. And then we can talk about this increases moisture content, increases soil moisture, and obviously the vegetation that is found in this place. Soil moisture and vegetation, which also soil moisture and vegetation, and eventually what increases biodiversity. It eventually increases biodiversity. It increases eventually biodiversity. We can also talk about also other point that has to do with it also continuous flooding. Continuous flooding also, it can also create wetlands. Continuous flooding can cause wetlands. Continuous flooding create wetlands for various wildlife habitats. We can also talk about what is it? They can also allows for the availability of water to be stored for animals. Availability of water for vegetation and animals. It's also a good point that we can also put in that regard. And then also flooding may also increase water quality. Flooding may increase water quality. Flooding may increase the water quality. That is also some other points that we can also talk about. You can also talk about uh, continuous rise in water table, continuous rise of natural water table, and then obviously, and availability of uh, enough soil moisture, availability of enough soil moisture. So these are points that we can put quite a lot of them with regard to the effects of explain the effects, explain the physical impact of flooding on the floodplain. So obviously this has to do with the positive effects that would arise from the waterlogged soils that reduce access to parts of the floodplain. Sometimes that would also happen there, and then continuous flooding, which also purifies water, and then also water quality improves there. The availability of wetlands that can also create habitats for various wildlife that we can also mention in that regard, and then also increase in biodiversity because of variety of organisms that are also coming into this, uh, both plants and animals. So I'm sure that these points they can actually relate and make good sense to this question. And then the river capture is a question that we have answered quite a lot of times again. And please refer to the channel also about the question of river capture. The question on river capture, we have answered it quite a lot of times. And I'm sure that you will never go wrong. And because of that, I'm saying it has been answered quite a lot of times. Like that, we might not actually need to continuously do it again and again because of time. But let me just answer this quick. I can just maybe try to answer this question very fast. River capture is when more energetic rivers captures the headwaters of less energetic stream. That's what you call river capture. More energetic stream captures or uh, behaves the waters of more energetic stream captures the headwaters of less energetic rivers. That is what we call by river capture, more energetic when more energetic when more energetic stream captures the headwaters of less energetic streams or rivers. We call that river capture. And then state one condition needed for river capture to take place. River capture, for it to take place, there should be a steeper gradient on one side of the watershed. We are saying one steeper gradient on one side of watershed. Obviously, where the water should be flowing faster, and then we also have to, there should be more rainfall on one side of the watershed again, more rainfall on one side of watershed. And then number three, you can say less resistant rock on one side of the watershed again. Availability of less resistant rock on one side of watershed. And then sketch. Draw a sketch to illustrate the area after river capture has taken place. Marks will be given to those. I can just quickly show the processes of river capture. I can just quickly show this one. Draw a diagram to capture the diagram of river capture. The diagram illustrating river capture. I can just quickly make a sketch here, which can be something like this. So we can say this one, elbow of capture, and then I can say the wind gap. I can say the wind gap. I can say this one is the misfit there. So I can say again, this is our river Z, and then river Y that was shown there. And then we can also have this, what you call kind of so what is happening is just a small diagram like that. It can show the watershed. The thing. This one is showing the wind gap, the point of alluvial deposits that are found on the space between the beheaded stream and stuff, and then the elbow of capture. It is the angle from which there was. Remember this river. It adjusted in this way, and then it captures that stream there. Therefore, we are saying that is a river capture that has taken place there. And then will river Y or Z experience rejuvenation after river capture? Which river Y or Z will experience rejuvenation? We are saying rejuvenation will take place because the waters are now from this river here. I can say the waters are flowing from here, and then they enter into this river here, into river what? Into river, they come and join into river Y. So it is river Y that can have more and more because of increase in discharge. Y can have rejuvenation. Y is the one that would have rejuvenation. Z will dry out. Z will dry out. You need to understand that Z will dry out. And then give reason for your answer. I already said that it is Y because I already said that Y is an increased volume of water because of increased volume of water, because of increased discharge or volume of water. That is why Y can have more water because of increased discharge or volume of water. refer to and explain the impact of change on the capture stream. Refer to the question and refer to the impact on the capture stream, So we are saying one, I'm gonna just quickly list these points. Increase vertical erosion due to what? Increase the volume of water in Y. We have got in a capture, it has got to undergo increased vertical erosion. There will be increased vertical erosion due to increased volume of water, due to increased discharge. And then number two, what else are we saying? Increase volume because of that. And then there is also active erosion of river. We are saying the active erosion in the river cuts into the valley, forming terraces. Terraces are formed due to erosion. Increased erosion will take place there, and then it will cause terraces to form there. And then we have got our next question. I mean, another point that we can give also, we have got also, we get also river rejuvenation will result in rivers within a valley, or river rejuvenation results in formation of a valley within a valley. As to say, the increase in river energy will cause rivers or erosion to take place within the same river, therefore. And then we can also have a nick point can develop along the profile of the river channel. Nick point will develop along the river channel, where the headwaters are now converted into the what? Into the more energetic stream also there. And then we can talk about also one other last thing, increased flooding because of greater volume that can also take place there. And then increase the velocity of the river channel because of greater volume. And then the capture stream will be able to carry a lot of a greater load. And then obviously less deposition will take place. All those are various points that we can put with regard to that. So please note that we can give as many points as possible. We are saying increased volume, less deposition than erosion. We are going to experience those things such as dot, and then obviously discharge will increase by nature. So class, thank you so much for your time, and then thank you so much, and please don't forget to share. Don't forget to share, and also